Well, welcome everybody. Welcome back. I hope everybody's had a lovely Easter break. Today we are going to be delving into the detail behind the brilliant SkyDome project on kind of P&O Cruises' latest ship, Iona. We're very lucky to be joined by two fantastic guest speakers. The first of which is brand director Geraldine Phillips for P&O Cruises. Geraldine's been working in marketing for over 18 years and has worked for and led a number of high-profile brands, including Marks & Spencer's and Noble Foods. Martin Francis is a leading designer and founder of Francis Design. Martin's worked in both the marine and building design industry with the likes of Sir Norman Foster, and was the F of RFR with the late eminent engineer Peter Rice. Alongside those two guest speakers, we've got our engineers Cosmas Mugapitsalu and Lorenzo Santelli from our Glass and Complex Structures group. Cosmas is an associate and leads on some of our most complex projects around the world. And Lorenzo is a senior engineer who is on our digital design group and specialises in geometrically complex projects. I'm Catherine Smale. I'm marketing manager for Eckersley Callahan. And so I'll just kind of take you through a couple of things before I start and hand over. So as you'll probably know from our previous webinars, but if you're new to this, I'll take you through it. So there's a little chat function up in the top right-hand corner or right side of your screen. And it's always nice to hear from you. I can see that people are already chatting away on that, which is nice. And it's always nice for our speakers to kind of know that they're not just speaking into a screen. And then similarly, we'll have a Q&A session at the end of the presentations, and so you can put your questions into the panel in there as well. And so if you like a particular question, then you can give it a little thumbs up. That's all from me for now. So I will now hand over and put you in the very capable hands of Geraldine.
Okay, thank you, Catherine. Welcome, everyone. I'm Geraldine Phillips, and as Catherine said, I'm the brand director for P&O Cruises. So my role in the webinar today is to talk through our vision for Iona, a bit of background, what our guests were telling us that they wanted, and therefore what our design brief was before I hand over to the very capable people who made it all happen. So first of all, this is our beautiful ship, our Iona, and hopefully, and will be on our shores within very soon, within a short space of time now in the summer. And we've waited a little while for her with everything going on, but we're so pleased that she's going to be coming to the UK and starting cruising this summer. And Iona is all about your ultimate P&O Cruises holiday. And it's a ship that makes the destination and see the star. And you'll see that theme come through consistently throughout the presentation and then also the designs. Iona was born to do things differently. She is more informal. She's supposed to be immersive, great experiences on board, and really adapt to the culture and the countries that she's visiting as well. So that's our vision really for Iona overall. And these are some facts and some background sort of Iona. She is the newest ship to join our fleet. The last time we had a new launch was in 2015 with Britannia. So it's a really big moment for us to be launching Iona. And she's got a pivotal role in redefining the brand and broadening our appeal. She is completely different to the rest of our fleet. She will open up further capacity and really appeal to new cruisers in the UK, as well as our existing guests. We'll always get quite a lot of existing guests on the new ships, even though often they'll say, oh, it's a bit big, or it's a bit too modern, or it's a bit too new. The curiosity and the sort of demand for new experiences means that they very much like to come on in particularly the maiden season, and then often keep coming back. But Iona presents the opportunity for us to get new cruisers into the brand as well. So she's really important to us for that. We've worked with designers on new venues, so completely new to Iona that you won't see on the rest of our fleet, as well as our fleet favourites, which we know our guests will want to come back to again and again. I know, will also be year-round. So she's cruising from Southampton to Southampton. Her main departures are to the fjords and Western Europe, and also into the Canaries in some of the winter months. So this has been a consideration in the whole design of the ship as to where she's heading. And the SkyDome and the glass roof is a brand new concept for the brand and the UK cruise market. So a real point of difference for us. And also, I don't know how much everyone knows about P&O Cruises on the call. So just a few stats on P&O Cruises as well. You know, we're the #1 UK cruise brand. And when we were up and running and sailing, as the whole of the travel industry was at the time, we'll get over 500,000 guests a year. So we get a lot of guests coming onto our fleet, and always after new experiences and new exciting news. Iona is also the largest ship to fly the P&O Cruises flag. She's 185,000 tonnes, just to give you some stats on her. 17 decks, and she's also Britain's first LNG powered ship as well, so our sort of green and innovative ship for our fleet. So, and there'll be just over 5,000 guests on her. So a really huge addition to our fleet at P&O Cruises. So some of the principles that guided the design of the guest experience are really taken from what we know about what guests want and also our experiences across the rest of our fleet and our business. First of all, no one wants to spend more time indoors on holiday than at home. They want to be outdoors, and how can we help to make sure that we embrace the outside is a key part of our design. Magic moments seal holiday memories and provide that social currency. Everyone loves those stories when they come home from a holiday to tell their friends and family and talk about those great experiences. So we want to always design ships for wow moments, and how can we make those happen? Third is being close to the sea is fundamental to what makes our holiday unique. You might say, well, that's quite obvious, but actually, how do we really hero that? You know, that's a really unique part of what we offer. So making the sea the star in all the design choices that we're making is really, really critical. Tranquility is important, but it can be hard to find on board, and some people feel that there's a lot of people on board. So again, in our design, we want people to find their own space and have those areas where people can get the space and get the quiet moments. And for British cruisers, destination is king. So we want to really bring the shore on board. How do we bring that destination to life? That yes, people are going off and exploring it, but then we can bring it to life on board as well. So those are some of the key principles from a design perspective. And then there was specific research done as well then really around this area that we're talking about today, the SkyDome and the area on our top decks. And this was carried out with focus groups, broader research, a whole mix of newcomers, loyalists, and a range of demographics to really understand what they're looking for in this space. And they were shown concept layouts and assessed the appeal of the space, the architectural style, some options around the roof and the whole experience. And these were some of the key themes that came out really. First of all, guests love venues with stunning views. And they treasure those outside spaces. And the fact that this venue is not weather dependent is a really key thing, particularly, you know, in the middle of the sea. It's pretty blowy at times. And how do you really bring this to life and have a great experience all day and it not have to be weather dependent is a key one. Guests love the outdoor feeling, natural light, love seeing the stars in the night sky. So making this possible and doing it in quite an organic space is what they were looking for. Holidays are all about living al fresco, and the SkyDome enables you to feel you're outside and connected with the sea and the sky. And that's, as we said, around making the sea the star and feeling connected is really important. The SkyDome increased the time guests can stay outside and really created that summer holiday feeling, even when they were sailing from Southampton or in the fjords. And our guests love fine spaces, scale, splendour, especially on the new ships. And this is a really key factor for the design because it needs to be high quality, it needs to be aesthetically impressive. And when certain versions, and I know Martin will come on and talk about some versions that were looked at in the research, what did become clear is sort of a cloudy roof or something they couldn't see through would make people think they're just simply almost in an indoor pool or indoor area or a covered theatre. And actually that glass and that see-through was vitally important to them. So that's what our guest told us, and therefore this led to the SkyDome. And SkyDome, first of all, is that wow moment. So answering that initial brief, it's a game changer that really differentiates the ship and us from our competitors. And it's a fundamental part of our launch story. So we've already been talking about the SkyDome a lot in the run up to the launch, and we will be talking much more about it, and can't wait for guests to experience it. It's a brand icon, distinctive, unique. It embraces the classic British glass design, and it has been developed by world-leading designers. And, you know, our vision at P&O Cruises is about creating extraordinary travel experiences designed in a distinctively British way. That is absolutely at the core of what we're all about. So this is really delivering against that. It has the transparency, the enhanced sense of being outside, and from an operational perspective, there's obviously minimising external weather noise and it being durable, etc. So there are obviously a lot of operational elements. And then these are some sort of visuals of how it will look from day to night. So it's the perfect place for relaxation. There's dining, there's brilliant entertainment, whatever the weather. So by day, you enjoy a relaxed poolside environment. There's tantalizing dining, there's lots of drinks options. It's a great interactive space and social space. But come evening, it transitions into a must-see venue. So we have spectacular aerialist performances in here, which is again a very new offering for us in P&O Cruises and something that's new on Iona, and then also party nights under the stars. So this becomes a fantastic evening venue for us. And then this all led, my final slide, to the design brief. And just pulling a few sort of key things out from here. So first of all, it needs to be a standout signature space. And it has to combine the relaxation, the poolside, the entertainment, the dining. Sky views and light flooding in that makes you feel like you're in holiday mode. It needs a clear direction to create the wow moment and bring the outside in. But also all of our designs need to have that consideration around our nautical heritage. It is one of the 4 primary entertainment venues and a real fresh alternative to theatre. The overarching theme we've talked about is making the sea the star. Natural organic design using wood, sculpture, plants, etc. It's 2 decks high. It's flooded with natural light. Deck 17, it's deck 16, deck 17, and 17 is the mezzanine level as well that looks out over the area. There's a triangulated glass design, which I'm sure we'll talk a lot more about, feeling more contemporary and distinctive. You've got a whole range of venues in there, as I've talked about, and then reflecting the best of iconic British architecture. Fully transparent glass roof rather than cloudy, and consideration of noise levels, as we talked about. And there's also then the more operational considerations for this design around LES equipment, maintenance and cleaning as well, that are absolutely critical for maintaining this space. So that's an overview of what we were looking for, what our guests were looking for, and the brief around the SkyDome. I'll now hand over to Martin, who can talk through then the design.
Well, hello. I just start off very briefly by introducing myself and how come a furniture designer, which is what my training was, gets to designing bits of cruise ships. I mean, I started off I studied furniture design and became a cabinet maker. And but the only piece of furniture I did after that was working with Foster when I worked on this Nomos table and making it a production thing. But I became, a long time ago, known as the glass man because I did this glass wall for Foster's. And I got heavily involved with glass, which has been a sort of theme in a number of projects going on ever since. I then joined Peter Rice to form RFR in Paris, where we designed this whole system of suspended glass, wire-stayed glass facades, which had never been done before. And this actually was based on a whole lot of technology, mixing of technology, using the manufacturers of rigging for yachts and for aircrafters who manufactured this this bolt, which you all see now as a means of supporting the glass. And this was the original drawing done by Hugh Dutton of the bearing embedded within the glass, which is now sort of common knowledge, but at the time it was sort of groundbreaking. And that led to further on to I was asked by IM Pay's team, who were working on the pyramid. They'd got the pyramid designed for Paris, but they didn't know how to make it stand up. And they said, "You do yacht rigging. How do you make it stand up?" And so I got involved with introducing something which has been a sort of common feature of my career, of taking one technology from one industry into another. I introduced IM Pay and the engineering team to a firm called Navtech, who made rod rigging, and they got the job and they did this rod rigging. And then they set up a new company, which is now called Tri-Pyramid Structures, which of course Eckersley O'Callaghan and many of you know very well, because they are the leading suppliers of this sort of structure. And it came out of this cross-fertilization between two things. So then my introduction to P&O was, in fact, a long time ago. I did this vessel for them called the Iona, and I can't remember how long it was, but it was probably getting on for 20 years. And I did all the external shaping, and at those times where I had much more freedom in terms of the external shaping we'd do on the sort of superstructure and so on. But I had a very marvelous working relationship with them. And then, sort of 15 years or so later, they asked me if I would be interested in helping on the external styling of their new vessel, Iona. And I sort of proposed all sorts of things, sort of modifying the shape of the bow and various other things, many of which didn't sustain themselves for various reasons. But one of the things that they were talking about was that they needed a dome over the central area, which you can see here in the middle of the ship. And the way the cruise industry works, although not the cruise industry, but the shipbuilding industry works, they take a ship design and they modify it for each client. So Carnival, which is part of the parent company for P&O, had already got a ship in which they got an ETF. It was proposed, it hadn't yet been built, but they proposed to have an ETF roof. And the weight and balance of the ship was dependent on the light weight of an ETFE roof. But as Geraldine was saying, when I got the brief and started talking to them about this, I said, well, are you really sure that this is a suitable roof for a vessel which is going to cross the Bay of Biscay in winter, go to the fjords and so on and so forth? It looks great this was the rendering at the time by the designers, which is, super transparent and wonderful. And this is the reality where the structure is a bit, and this is the vessel new. And my whole speech to P&O was, you've seen the ETFE roofs at Gatwick and Heathrow Airport, and they look pretty crummy. And when it rains, you hear it all. So I said I wouldn't recommend that, and I suggested we went for glass. And the question was, the shipyard said we can't afford glass; it's too heavy. So I came up with the idea of thinking, well, I think it is possible to do it. And I introduced Eckersley O'Callaghan to the project. And I said, whatever you do, even if you don't employ me for the rest of the project, you should employ Eckersley O'Callaghan. So started a very fruitful relationship. And I worked out a way, because they had a plan form which was an oval. And so it was necessary to create a shape of an oval shape, which was the plan shape here, on a geometry that had combined a lot of repetition. So, as many of you will know, a torus is a famous sort of engineering device to giving repetition in buildings and used in all sorts of things. I think Kansai, I remember Peter Rice saying that Kansai was part of a torus. And so I came up with this geometry. And one of the strange things about somebody in my generation is I do everything. I work myself in 3D, and I do the 3D modelization and testing all these things out. And so this was my early model, where the different colors represent the different panels, which are all repeating. And this was, but then my sort of first geometrical model. And obviously we had then, because it was a dome, you're going to have peripheral stresses. And so we then talked about putting an annular ring around it in the form of sort of sunscreen. So this sort of thing. So basically that's my introduction. And the guys who made it all work, as Eckersley O'Callaghan, to whom I now hand over.
Hello everybody, it's Cosmas, and together with my colleague Lorenzo, I will try to go through the whole process we have followed as Eckersley O'Callaghan for the design of the dome until its completion. First of all, just to remind ourselves the project team. So apart from the client, P&O Cruises and designer Martin Francis, we also need to mention the shipyard, Meyerwerft in Germany, who is responsible for the actual vessel, and also the glass dome contractor, Fren and Reifer, who are based in Italy. So the design brief. When we started working on the project, the three things that we had to accomplish basically was a glass roof, for which the weight had to be equivalent to the initial ETFE design, because as Martin mentioned before, due to the location of the dome at the top of the ship, a minor increase would cause stability issues and also massive redesign for the shipyard. And also the glass had to be insulated, so insulated glass unit in order to meet the thermal performance requirements. Here I have summarized some of the design assumptions that we had to consider before even starting the design. So first of all, the dome had to withstand wind loads, approximately 2.5 kPa for the global structures, snow loads, accelerations in all directions due to the ship's movements, maintenance loads because the roof had to be walkable, M&E loads, deformations of the supporting structure, because as you can imagine, the ship is like a living organism, and as it moves in the sea, deforms, and this deformation needs to be accommodated by our dome. Fatigue, and also the stiffness had to be such in order to avoid resonance due to the sea excitation, the waves, and the propeller and the engines. At the same time, apart from the structural assumptions that we had to consider, also had to meet some specific thermal performance requirements. So the U value had to be 1.8, G value 0.2 to 0.35, and also something very important, which was a basic requirement from the client, was the dome to be as transparent possible. So minimum light transmission 60%. Before even starting working on the project, we had to carry out an initial coordination with RINA. RINA is a classification society. It's the society who provides the rules and regulations for the vessel, and including the dome in our case. So they had to approve in a way our design before we move forward. So we provided the concept report, and they came back with some questions. Obviously, they did have some experience with glass, because glass is not uncommon in marine industry, but not in that particular application. So basically, they asked us if the insulated glass unit, if both panes of the insulated glass unit, the external and internal, can work structurally at the same time. They were assuming that only one layer can work structurally, the bottom and not the top, that provides the thermal insulation. Also, they wanted us to use only fully tempered glass, which is stronger. And this is the reason why it's common in the marine industry, the massive wave loads, and not any other glass type. And also, they were worried particularly, since we were trying to use both panes of the insulated glass unit structurally, they were worried particularly what will happen in case of an impact due to a hailstone. So we had to answer these three questions before the design moves forward. So regarding the first question, it was quite easy to respond because it's using both paints of an insulated glass unit. Structurally, it's quite common in the facade industry. So simply provided reference from previous projects, design codes, and we're happy with this. So the other two questions I'm going to describe in a bit how we managed to solve. Going back to the design brief, the main aim from the shipyard is to keep the weight within the ETFE, the initial ETFE design roof limits. And this is quite complicated so how to optimize the weight. So this is quite complicated to do it manually and get the optimum results. So what we did in that case to combine rhino, grasshopper, and strand in order to achieve that. First of all, we carried out a section optimization. So what we did was we developed a script in Grasshopper, which carries out an iterative process for each member size. And for each member size, selects a section from a library of cross sections and checks if stresses, deflections, buckling, all the stress we usually do as structural engineers, check if all of these are within limits. And for each member, it picks the right section in order to achieve the most optimum solution. So that's what we did for the section optimization. But at the same time, if you remember, we had to keep frequency at the same limit and also the weight at particular limits so that it can be within the previous ETFE roof design weight. So again, we used same script in order to do that. But obviously, after some point, increasing the section sizes doesn't really help with the weight. So we used that script in order to find the perfect balance between the weight of the roof and the frequency, so that are both within the allowable limits. Obviously, we did after that, after having like a global model which was more or less working structurally, we've carried out more detailed checks. First of all, we started with the glass panel. We ensured that the glass thickness we're proposing is within the limits. So we've applied the uniformly distributed load, which is quite okay, and also maintenance load, so a point load at the center of the panel, because the panel had to be walkable. Also, we've carried out checks for the global steel structure and checked stresses and deflections for this. We've paid particular attention on the global buckling behavior of the dome, because I forgot to mention before, just to give you also some indicative sizes for the geometry. The length of the dome is 40 meters, the width it's 30, and the height only 4 meters. So the dome is particularly shallow, and structures like this are particularly critical in global buckling and snap-through buckling, which means more or less sudden loss of the global structure stability. So we've carried out a nonlinear geometry analysis to understand what the buckling factor is, and in that nonlinear geometry analysis, we also induced the expected imperfections, and this was like within limits. Next slide is about some typical details that we have adopted. On the left-hand side, you can see the detail we propose for the support of the IGU panel, insulated glass unit, to the steel structure. So initially, we've proposed to have a toggle fitting so that we don't have anything outside the glass surface. But unfortunately, during the involvement of Frennan and Reifer, Rina was a bit worried that the external pane will not be supported mechanically. In our detail, it's only supported by the silicon of the insulated glass unit. So they've induced mechanical restraints, so patch fittings, several patch fittings per side of the glass. During the detailed design, we've also spent some time to explore different node options. Some of them are shown here. For example, the top left is just a solid cylinder with sections welded around it, or on the top right, steel plates forming a star-shaped node, and then again, the box sections are welded around that. But what the client liked as the most aesthetically pleasant solution was to have a central node made of milled steel, and then the sections welded. So on the bottom right, you can see the actual a completed node. Finally, one last detail is the glass build-up. As I've explained before, it's an insulated glass unit. The external pane is made of fully tempered glass to withstand impact due to hail. Fully tempered glass is much stronger than any other glass type that used in marine industry, and will have better performance in case of a hail impact, and also during the maintenance of the dome. Then we have 16mm argon inside for thermal insulation, together with the high performance coating on surface 2. And on the inside, we have 2 plies of heat strengthened glass. So we were really pushing hard Rina to adopt this solution, because based on experience, heat strengthened glass, we know that the breakage pattern, as you can see on the right-hand side, is like to break in large pieces. So when the glass breaks together with the interlayer, the fragments interact all together with the interlayer, and they have an increased post-failure behavior. So this somehow ensures us that even if the vessel is located at the middle of the ocean, a glass breakage will still, even if you have a glass breakage, the panel will still be in place, as opposed to a fully tempered glass option that Rina wanted to have initially, where basically in case of breakage, you have loss of stiffness and there is the risk the panel to fall off. So we handed over the design to the glass dome contractor, Frennan and Reifer. They started to be involved. They produced the details, the drawings, and after some point, when the drawings were approved, or even before they were approved, we've carried out a visual mock-up just to ensure that the client is happy with what the contractor has proposed, and also to ensure that the glass has the desired optical quality. And as you can see, everything goes fine. So the next part is about testing, and Lorenzo will take the lead on that.
Thanks, Cosmas. Alongside, in parallel to the visual mockup, we carried out some tests, and we carried out some performance mockup as well. And this is quite an interesting one, because it's for the hail test. Prior to the hail test, we did some EVA analysis, trying to understand how we could define the thickness of the glazing in order withstand the impact of the hail. This wasn't a very simple task, because it's quite difficult to apply this force within the FEA world. And so then we studied internally, and we did some research to understand how we could actually find an equivalent load, a static load, to represent the impact of hail. And then we proceeded with the test. The test actually is not really a standard one. It's based on an American standard, but basically it was based on the creation of ice balls and shooting them with a kind of bespoke cannon. And it was quite interesting, especially at the very beginning. And we had like roughly 121 targets per panel, and we tested more than one panel. And the outcome of the test was positive, and so we could keep the build-up that we designed in the first place. And you need to imagine that having 2 millimeters more, adding 2 millimeters more of one glass panel, it means that the amount of glass, the amount of tonnage, it will increase a lot for the whole dome. So that's the reason, because it was quite critical test. Alongside this test, we ran some other more standard tests. For example, this one has a uniformly distributed load with sandbags as well. And this one as well, that is basically part of the CT fragility test. And starting from hard body and soft body test on both planes of the AGU, and then leading to a more interesting test on the post-breakage behavior of the glass. As Cosmos mentioned it before, there was this question between us and Rina to understand if the heat-strengthened glass was the best solution for this particular application on the dome. And basically, we ran the test on both the two cases with fully tempered glazing, laminated heat-strengthened glass that actually, when it breaks in large pieces, so retain a large amount of capacity. Basically, the test is applying 180 kilos on the glass pane, and that simulate two people staying on the glass. One is actually injured, and the other one is trying to help the other person while injured on the glazing, and all the panels are completely broken. The outcome of the test showed us that the behavior of the strengthened glass proposal was much better, and it was a great help to for the use of this type of build-up. The installation of the dome basically was based on a particular procedure where the dome was actually fabricated in Italy at the Frene-Reifers facility. Then the dome was shipped in pieces and assembled really close to the shape at Meyerwerft in Papenburg, Germany. And while the steelwork was assembled, a warehouse was built around, especially to protect the dome while the final coating was applied to the steelwork and during the installation of the glazing and the silicon. It is quite interesting to see that basically almost 99% of everything related to the dome was assembled and installed at this time. Prior to the final lifting. Basically 99%, including services and speakers and other elements required for this particular location. And we can see here for the final lifting that basically is almost completed aside from few panels for requirements due to the final installation and the connections on top of the ship. A huge mobile crane was actually necessary because the crane provided by the yards couldn't withstand the load of the dome. And we can see here that you can see the speakers on underneath the dome and all the other elements. And finally, this is an image of the completed ship with the dome on top. And for us, I think we're done. Thank you very much for listening to us. And I'll leave the stage to Catherine if there are any potential questions. Thank you again for listening to us.
Super. Thank you very much indeed, guys. It's a fantastic presentation. And thank you so much as well for kind of Geraldine and Martin for joining us. It's kind of the projects that we do are obviously all about the client. And so to have the clients joining us and the designers joining us is kind of, I think it speaks volumes about sort of the collaboration and the work that we do together as a team. So thank you very much. The work that's gone into it is spectacular, isn't it? In terms of, what strikes you as being, the hail test, the research that was done to do that, and then the actual sort of testing and the outcome of doing all of that. That's super interesting. And then I bet it was a spectacular day to kind of watch that being lifted into place. Such a huge kind of, culmination of everything coming together. And so that must have been a fantastic day to kind of to see going forward. I've just got kind of a couple of questions. Geraldine, I mean, I know this is slightly unfair in terms of a question, but have you had any feedback on it yet? You haven't opened yet, so I guess this is kind of a bit preemptive, but have you had any sort of feedback on it?
Yeah. I think from the original sort of initial launch communications and the visuals that people have seen, it's a very, very exciting space for people. So yes, guests are excited about seeing it, experiencing it, the fact that they can be in the day in whatever weather, but also then the night and the evening, and what it opens up for us to be able to do from an entertainment perspective and dining perspective in the evening as well is completely different to what they're used to. So yes, very positive from the visuals that we've been able to show them. We haven't really been able to do it justice yet, because once we get her over to the UK, and then we'll take some really great photography then and do some more. So we've given them glimpses, but not really brought it all to life enough yet. So good so far.
Good things come to those who wait. I think it'll be fantastic when it kind of comes over. It'll be super. Sort of throwing it out there to sort of, I suppose, kind of our engineers and Martin, in terms of, do you think that the shipbuilding industry, we've kind of, do you think that it's kind of open to new things in engineering because of this? Do you think that you've sort of been able to persuade them that new things are possible within the industry?
It's I'm tempted to say they're getting there kicking and screaming, but it is. I think this is a good demonstration of the shipbuilding industry sort of saying basically no, and then getting. And I think it's fantastic the work that Eckersley and Callan has done, because rather than an ordinary engineer or even if I was an engineer proposing something like this, it would be shot down by the shipyard and by the Classification Society. But by involving right at the beginning the Class Society, RENA, and going to the roots of all the regulations, we've managed to get this through, and it will undoubtedly have a knock-on effect. I mean, I'm working with Eckersley O'Callaghan on 3 or 4 other domes for other ships, and including the successor to this vessel, and so it's the first of many things, and I think the use of glass in these ships will only increase.
Absolutely. I bet the competitors are shaking, kind of going, we've got to catch up now, I suppose, haven't they? So that's
yes. I mean, therefore, it's the competitors. Often the competitors are in fact part of the same company. So that, I mean, the holding company, if you like. You see, brand, but Cunard is a brand under the same holding. So it's all, but there is a competition, obviously. Yes.
Absolutely. The questions look to be coming in thick and fast from these places. I mean, Stephen John seems to be is very impressed by the accelerations in all directions. I mean, kind of, it's not something which we get kind of in building design, is it? So it's that is something which is very impressive with it. Darmud asks, how are the wind loads? Excuse me, sorry. How are the wind loads calculated, given that the ship can move around the world?
So basically, the dome has been calculated to a particular design pressure. So RINA and most of the classification society that they provide the regulations on how to design the vessels like this, provide design pressures for every, let's say, deck level. So when you have a dome or any sort of structure in that particular location, then the design pressure is approximately equally to, not approximately, it's 2.5 kPa. So regardless where you are, every part of the world is always 2.5 kPa pressure. What we did, pressure and suction, basically both. What we did from our side, because we weren't feeling confident simply to apply 2.5 pressure, 2.5 suction, we also adopted wind load distribution according to Eurocodes. So apart from design pressure and suction load, we've also applied asymmetric wind load distribution. Because that's what we were feeling right to do.
Presumably just to make sure that sort of that 2.5 was the most onerous of the conditions, and that you weren't going to exceed that with any other kind of area. Yeah. Michelle asks, what's the total weight of the dome?
It's 130 tons, out of which I have kept minutes, because there is also another question: what is like the many? So it's 130 tons, out of which 120 tons it's the weight of the steel and the glass. So the steel is 67, the glass 52 tons, in total 120. And then we have additional 10 tons for superimposed dead load, and this includes everything. Like, I don't know the exact breakdown, but many loads are within this 10 tons, but the majority of the superimposed dead loads are basically M&E loads there.
Because it's an optimized structure, isn't it, in terms of sort of making sure that the weight was as low as possible for the actual structure itself, wasn't it?
Yeah, exactly. So basically the glass, the glass thickness was optimized, but it's an infill panel, so it doesn't take part on the structural system. So we optimized it as much as we could in order to meet the thermal performance and the structural requirements. And then the 67 tons, this is like the weight of the steel that was like optimized to the grasshopper script that we showed before.
Yeah. I'm just going to kind of go through the questions, really, I suppose, because they've come in quite quickly. So what's the main frequency of the dome? Is it compared to? Oh, sorry. So what was it compared to? So the frequency of the dome.
I don't remember the exact number, but the mode is more or less similar to the one we are showing. Yeah, something like that. And regarding now to what it was compared to, when we received the specification of the ship, so they provided that the ship provided particular frequency limit. So they told us that the propeller vibrates in that frequency range. The engine the same, and sea excitation is that. So in a way, we've tried to avoid these frequencies.
Was that a problem? Was that a challenge in terms of finding a frequency that wouldn't then interfere with the other ones? Not interfere, that's the wrong word, but wouldn't then match the other frequencies?
It was quite difficult, basically, after some point, because as we showed in that diagram, even if we were trying to make the dome stiffer to avoid these frequency limits, then the total weight was increased significantly. It was outside the ETFE roof limits. So what the shipyard did after some point, they carried out the forced vibration analysis in order to understand if actually, let's say, the vibration of the engine that is located somewhere at the bottom of the vessel actually influences the behavior of the dome, which is on top. And the conclusion was that they are so far away that it shouldn't be a problem, something like that. So partially the problem was solved like that by proving that it's not going to be an issue.
Wow, it's all in the design considerations. Was carbon epoxy considered in view of saving steel, say in view of stiffness and weight savings instead of steel?
So, sorry, can you repeat that?
So instead of steel, was carbon epoxy considered in terms of stiffness and weight saving?
Not as far as I'm aware. Lorenzo, do you know something more?
We have on another project for the same client. We have looked at it. There are problems to do with cost, and there are problems to do with fire. And so generally, I mean, we haven't come to a final conclusion, but mostly when we've analysed it cost-wise, it breaks the budget. I think it will happen, but there is one of the contractors who's making glass sort of covers for ships who are proposing it. So I think we will get there. I think, but fire tends to be a major problem.
Mm. I guess with all of these things, as you were saying before, you've got to be able to prove it to the regulators, and therefore, as you said before, kicking and screaming, but not quite. Let's not push it far better. But one day.
Question there, which I'm sure that is about whether we could consider aluminium. I think Cosmos could reply to that better than I could.
No, we didn't consider. I mean, aluminium has 1/3 of the stiffness of the steel, so I assume that this would mean bigger sections. So as far as I'm aware, the aluminium was not considered. So directly it was steel.
Yes, I think there were some fatigue challenges as well, and then the lifting case scenario was one of the driver of the ring beam and some elements as well. So it was a mix of things, and steel in this particular case was the ideal material.
Yeah. Just answering one there, kind of. So Bruce is asking about the movement. So lots of movement compared to a traditional situation. So how did you rationalize this?
Do you want to describe, Lorenzo, about the movement joint? But basically, let's say that in plan, the dome was like fixed in plane, and in the other half there was like a movement joint. So there was like an in-plane release, so that can accommodate the movements of the vessel. And at the same time, there was like a coordination with the shipyard to provide us the exact stiffness of the supporting structure together with movements. So all this information was like included in our FEA model. So we've added the movement joint, and at the same time we had information about stiffness, supporting structure, and also movements for hogging and sagging conditions.
And I think even the location of the dome was quite good at the center of the ship as well, and it helped a bit with the situation. If we would in a slightly different location, it would be more challenging to model and to actually design it.
Yeah.
Super. I think we're heading up to about 6 o'clock here in the UK at the moment, so we've got time for one more question now. I suppose we'll head off at the pass. So Michelle asks, on this project, what was the main challenge costs-wise? Obviously, the cost remains confidential, so we're not going there with that answer. But in terms of what was the most challenging thing costs-wise?
I assume that installation and construction, that's quite challenging to me, at least. I wasn't really involved into this, but to me, yeah.
I mean, I wasn't involved in the cost at all, but I can say that the industry, the cruise industry, is incredibly competitive. I mean, the shipbuilding industry, in order to build this, and it's really, if it didn't meet the bang for your buck criteria, in other words, if P&O weren't satisfied that it was going to give the wow quality that Geraldine quality, you know, they wouldn't have had it. So I think it was cost effective for what it was achieving.
Absolutely.
And even maintenance was quite tricky bit, because if a panel breaks at sea, it's not that you need to go to a port to replace that. And all that part of post-breakage things was quite an important part and had a kind of implication in cost as well.
But I suppose with that, I mean, it's kind of, you've got all the fail safes in place. So it's not as if, you know, sort of something breaks and something, you know, it's kind of imperative. And I expect that it's so large that actually one breakage kind of doesn't really actually make a huge amount of difference to the overall appearance of the dome. So it's kind of, it's designed in such a way that that actually isn't too much of a problem, I suppose. So I suppose that's worth saying. Geraldine, do you want to have the last word on the actual structure itself? Or do you want to have a kind of a last sort of overall kind of wrap up?
Yes, I mean, I think obviously there's an awful lot of expertise on the panel involved in this farm with me, but I think from a P&O Cruises perspective, I think we can say we're just immensely excited and proud of what has been achieved, and it's really exciting to be bringing this completely new space for us to guests and bringing that to life in the summer. We know they're going to love it based on everything they've told us, and it's distinctive, it's step changing, it's British design, and that's what the company and the brand are really, really looking for. So yeah, we're really excited about it.
And I think it's been, you know, from talking to the engineers and everybody else who's worked on it, everybody's really enjoyed working on it. And I think that really shows in its actual kind of the design that's been produced. And it's always brilliant when a client is happy. So thank you very much indeed. I think that's all we've got time for now because we've hit 6 o'clock. But huge thanks for everybody joining us. Martin, Geraldine and Cosmas and Lorenzo, massive thank you to all of you for joining us. Don't forget to tune in next week. We've got La Reference, which was our award-winning, kind of iStructy award-winning sustainability project to build a new school in Haiti after the earthquake. I think it was an earthquake that kind of completely destroyed quite a large area of that. Of Haiti. So join us for that one. I think that one will be a fantastic presentation. Again, they've just built phase 2, so we'll be able to kind of give you a bit of an update on that project as well. And so, yes, brilliant. I hope you will join us this time next week for that. And I hope you have a lovely evening. It's sunny here, not snowing for the first time in a little while. So hopefully everybody will go to the pub and with our newfound freedom. Super. It's been lovely to see you. And take care, and we shall bid you good night. Thank you very much indeed, guys. Take care.
Good night.
Bye.
Good night.
Bye-bye.